This is Mr. Anderson from KCC Math 101, and this is going to be a walkthrough of Section 7.5, a general factoring strategy. I strongly recommend that you download the documents from the Moodle page and also practice along on a separate piece of paper. Pause the video at times to catch up with my description and try to write the example out before I do it or as I do it. Practice makes perfect, and this works very well with Section 7.5 in your notes and book. All right, so we now have learned every way to factor that you're going to do in this kind of chapter. Now the big question becomes, well, if all of them are thrown at you at once, what are you going to do? Now, the first question that you should ask yourself, no matter what, and that first question is going to be, hold on, let me get my stylus ready here. The first question is going to be, is there something I can remove? Sorry about the closeness of those letters there. Is there something I can remove? So you're looking for something called a common term, which is your greatest common factor, or GCF. So taking a look at this example, regardless of how many terms there are, you have to look to see, is there something I can remove? Does 20 and 10 both have something in common? And the answer is yes. They both can be divided by 2, they can be divided by 5, they can be divided by 10. So we're always going to remove the biggest term possible. So we're going to divide each of these by 10. And I write it this way. You may not do this in your work, but that's how you would show removing or taking out a common factor. Now, you'll notice that each of these terms also has x's and y's in them. You can remove the amount of x's and y's that you have in common with both problems. So you can never remove more than the one that has the least. So for example, this one has x cubed and this one has x squared, which means that you can only remove 2 x's since you have to do the same thing from both terms. And because you can't remove 3 from the second term, you can only remove 2 from each term, which means that you can only remove how many y's? There's 1 y here and 4 y's here. You can only remove 1 y from each of these. So that means this first term, 10 divided by 20, makes 2, and 10 divided by 10 makes 1. In this case, it's going to be a minus 1. But we're not going to write the 1 because 1 in front of the variables is the same thing. But I'll do it right here, before I write my final answer. X cubed divided by x squared is just x. And then y divided by y is just 1 because you have no y's left, y to the 0 power. And this is 4 minus 1. This is y cubed. Now, this is in parentheses because what we did is we took that division of 10x squared y, and we kind of brought that out in front. So my final answer is going to be, and I want to rewrite it because of this negative 1 here, is going to be 10x squared y, what they both had in common, and then in parentheses we have 2x minus y cubed. And that is, you should ask this question before you do any problem. Is there something I can remove? And I'll be doing that for every problem that we do here today, just to make sure that we make the problem as easy on us as possible. The second question you should ask is, you should look inside the parentheses if you remove something, or if you didn't remove something, you should ask how many terms. And the answer is going to be either 2, 3, or 4. Now, if there are 3 terms, you have the easy method where there's no number in front of the x squared. Well, technically a 1, but you don't see a number in front of the x squared. And there's going to be the more difficult method when there is a number in front of the x squared and you have to take care of it. Now, let's go take a look at how many terms. Here's the example. The first question I'm going to ask is, there something I can remove? The answer is no, because there's nothing that the x to the 4th and the 16 have in common. Now, this has 2 terms. So my question now becomes, is this a difference of squares? Now, what's important about that is that you should look at here to ask yourself, okay, is it a difference of squared? Difference. Is there a subtraction symbol in the middle? Yes. Then, okay, we're good so far. Now, what do I mean a difference of squares? That means my x has to be an even power, like x squared, x to the fourth, x to the sixth, x to the eighth, so on and so forth. So I gotta have my first term, if it has a power of x in it, it has to be an even power. And my numbers have to be square numbers. So for example, 1 is a square number because it's 1 times 1. 4 is a square number because it's 2 times 2. 9 is a square number, 3 times 3. And you should probably get familiar with the first maybe 10 or so square numbers and be able to recognize them on sight. And by doing the homework in section 7.4, that will become easier and easier. So here are the first 10 square numbers. So, is this a difference of squares? Well, yes it is, because it's x to the fourth, so it fits that first, x being an even power. And it is a square number, so therefore, check it out, you've got all these square numbers here on the right-hand side. Now, what I would suggest is that you go and do section 7.4, and I'll just put this off on the side here because that's where most of that stuff is. Now, this is a difficult problem because in a difference of squares, it turns out that you take the square root of the first number, which is x squared, and the square root of the second number, which is 4, and then you put x plus and x minus, and that makes your pattern. Now, a lot of you will get to this step and feel it's pretty easy and then check the back of the book and notice you're wrong. Well, what happened here is that this x squared minus 4 is really another difference of squares. So this can be broken into x plus 2, x minus 2, and the first term, x squared plus 4, comes down again. So there you have it. There is your fully factored problem where you broke down the square root of x to the fourth and the square root of 16, x squared and 4, x plus 4, x squared plus 4, x squared minus 4, but this one could still be broken down further, and that's probably going to separate the difference between like a 100% and a 98% on the test. So be aware of that. It'll show up maybe once or twice. Okay, make sure you copy this down because I've got to scroll this down and that will delete everything here. Now the next thing I'm going to take a look at is I'm going to take a look at these three-term problems. Now the question you should ask yourself if you see a three-term problem is there a number before x squared? So that's the first question. Is there a number before x squared? And in this case, the answer is no, and that's a very good thing, because what we can have here is now we have the kind of the easy factoring. The easy factoring has you look at the third term, and this third term is a negative 12. And what you should do is list all the factors of negative 12, which is negative 1 and 12, negative 12 and 1. You see these two multiply to make negative 12. Negative 2 and 6, negative 6 and 2, negative 3 and 4, negative 4 and 3. And then what you'll do is you'll try to find the way that these make the negative 4. There's only one combination that makes a negative 4 when you add these all together. And that combination is right there. So you found your combination that makes your negative 4. So here you have x minus 6, x plus 2. And now it's factored. Okay, question 3C. Now, we've noticed that in the previous three problems here, there's nothing I could remove from each of these terms to make the problem smaller. So, if I ask the same question, is there a number before x squared? So, this question gets asked, and the answer is a sad yes. Then we've got to use an alternative method that works with this 12 here. What I'm going to do is take the 12 and multiply it by the 2. That makes 24. Alright, so now this is some scratch paper work here. Taking the 12, multiply that by 2 to make 24. And now what I'm going to do is I'm going to list all the ways to multiply to make 24. So those ways are going to be, let's see here, that's going to be 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And I don't have to go any further because if I list 6 comma 4, notice I'm going backwards up the chart, so that's how I know when I'm done. Now, I notice that only two of these numbers can make a negative 11, and that's going to be 3 and 8. Well, what's good about that is that that makes the 11, but you'll notice that it's a negative 11, so I'll have to make these both negative, because negative times negative is positive, and the good news is that makes that number in the middle. So, here's what you do with this then. You're going to take your negative 11, and you're going to split it into negative 3 and negative 8x. Now, the order of these don't matter. If you did negative 8 and negative 3, you're going to get the same answer as me, but it's going to be, just a different, it's going to look different all the way until we get to the end. So, then I write my 12x squared, right there, and then I write my plus 2. Now, what I'm going to do, and by the way, this is from section 7.2 and 7.3. What I'm going to do is I'm going to use the method I learned in section 7.1, which is, we haven't talked about this yet on this worksheet, but the lesson in section 7.1 says if you have 4 terms, you're going to factor something out of each of these two pairs. And what I should find is a match in the middle. Now, let's look at the first two. What I'm going to factor out of 12x squared and 3x is always going to be something with an x in it, but in this case it's going to be a 3x. And that leaves me with 4x minus 1. Now, I've told a trick that anytime the third term is negative, you should pull out a negative. And so in this case, what I'm going to do is pull out a negative 2, because that's what these both have in common. And lo and behold, looky, you have a 4x minus 1. And I've told you time and time before, if you see 4x minus 1s, perfect 4x minus 1s, or perfect parentheses, you know you did the problem right. So the junk left over, the 3x minus 2, it gets its own parenthesis, a little bit of a reverse distribution property there. And then 4x minus 1 gets its own parenthesis, and congratulations, you've factored the problem. And this is probably one of the more difficult processes to learn and understand, and I would carefully go over this again and again until it starts to make sense and flow with what you're doing. Okay, I'm going to now move down the page here a little bit, and we're going to get to that fourth term problems. Now again, the question you should always ask yourself, is there something you can remove from all 4? Well, no, you can't. And you can't remove something from all 4 because each of these terms, they don't have anything in common. But just like in the last problem, and this is from section 7.1, we are going to factor something from each of these two terms. Again, watch that the third term is negative, so you're going to pull out a negative number from these two. Now in this case, the only thing we can remove here is an x squared, so this makes x plus 2. And what I can remove from here is a negative 4. Yeah, it's true that 2 does go into these two, but negative 4 goes into both as well, which makes this a positive x and a positive 2. And again, as I've said before, if you see that parenthesis matching up here, you know you did the problem right. So now I've got x squared minus 4, x plus 2, because the junk gets its own parenthesis and x plus 2 gets its own parenthesis. And we feel pretty good about ourselves. We'll check our answer in the back of the book if we're doing our homework. And the back of the book doesn't look like that, because it is very common at this stage to skip the fact that this might be another two-term difference of square problem. 90% of you will miss this if you're not doing your homework regularly or you're just not being careful about it. So it's a common mistake. So this, as we learned from section 7.4, and from the previous ditto, or the previous part of the problem here, this can be broken down to x plus 2, x minus 2. And then this x plus 2 gets brought down. Now you'll notice here that I have 2 of these x plus 2's, so it's possible I will accept this answer, but it's possible the book will write it like this: x plus 2 quantity squared, because there's 2 of them, and then x minus 2. So again, tricky problem at the end there. Many people won't see that. Alright, let's scan down and let's do the next side here. We're going to do a couple problems and then check it with FOIL. We'll do a total of 5 problems. So we'll do the first 2 here. And let me get my pen ready. Okay, so the first question I should ask myself: is there a number I can factor, a number or letter, or both I can factor out of these two terms? The answer is yes. And the number that divides 6 and 24 is 6, so I'm going to pull that out in front, and which means I'm going to be dividing this one by 6 and dividing this one by 6. Is there a letter I can divide from each of these? And the answer is yes, because I can divide out an x from each of these, so the x gets pulled out in front, which leaves inside my parenthesis 6 divided by 6 is 1, x cubed divided by x squared is, or x cubed divided by x is x squared. 24 divided by 6, that is going to be 4. And I've got x divided by x, which is just no x's. Now, because you were looking for the difference of squares on previous problems, you might say, oh wow, look at this, x plus 2, x minus 2. But you see how that's a plus in the middle? Can't do anything with it. So this is your final answer. And if you want to check with FOIL, distributing that back together again, 6x times x to the second power is x cubed, and then 6x times 4 is 24x. So we've checked with FOIL. You can check with FOIL on most every problem on the test. Now, I ask myself in this problem, before I get started, because you're saying like, oh no, it's an evil trinomial problem, but wait, is there a number I can factor out of this problem? And there is. You can factor out a 5. So that means each of these gets divided by 5. And then what that will make is an easy 1x. I'm going to write the 1 there. It makes it an easy problem because now since this is an easy trinomial, we have to ask ourselves what two numbers multiply to make -6 and add to make -1. So here's -2 and positive 3, -3 and positive 2. We've got -1 and 6, -6 and 1. Which one makes a -1 in the middle? It's going to be the first one that I listed here, -3 and 2. So this is going to be 5 on the outside, x minus 3, x plus 2. Now, I can check this with FOIL. Now, if I check it with FOIL, I will write the problem out again. It's according to order of operations, it's best to start with parentheses. So let's do our FOIL in the middle here. So x times x is x squared, x times 2, whoops, I'm sorry, my arrow should have reached over there. X times 2 is 2x, and this is -3x in the middle, and this is -6 at the end. The 5 is still on the outside waiting to get used here. This can be simplified on the inside, x squared minus x minus 6 multiplied by 5, and then multiplying everything by 5, 5x squared minus 5x minus 30 checks. So the check does work with the FOIL. Okay, let's go and take a look at the next problem here. Let me scroll to move this down. Oh, look, checking for viruses. Okay, I think I can fit all 3 on this page. All right, here we go. All right, so is there anything I can remove from all 4 of these terms? No, but since it's a 4-term problem, I can remove something from the first 2 problems, and I can remove something from the last 2. I'm going to remove an x squared, and that leaves me with, let's see here, x plus 3. And what am I going to remove from the last 2 terms here? I'm going to remove a -5 because it's a negative 3rd term, which leaves me with x plus 3. And now I have x squared minus 5 and x plus 3. And I know some of you are saying like, oh, Mr. Anderson, look, I can do a difference of squares here because this would be x plus 2.5, x minus 2.5. No, it doesn't work because this 5 is not one of those perfect square numbers like 1, 4, 9, 16, 25. So if this number doesn't fit in one of those, don't look to break the binomial apart. Now I can check this with FOIL. X squared times x is going to be x cubed. First term looks good. X squared times 3 is 3x squared. Okay, second term looks good. -5 times x is negative... whoa, what happened here? Looks like there was a type... I made a mistake here. This should be a 25. Oh, shoot. Oh, shoot. Looks like I can break this apart. Oh, nuts. Don't really want to go back and edit this, so forgive me a little bit. That should have been a 25, which does break this into x plus 5, x minus 5. Oh, crap. Sorry about making that mistake. And, wow, made a whoopsie there. Now, let's go check this out with FOIL. Now, what's interesting is now that I have 3 of these terms. That makes checking with this with FOIL not impossible, but more difficult. So I'm going to take the first 2 parentheses first. So this is going to be x squared minus 5x plus 5x minus 25. And I'm still going to have this over here, x plus 3. This whole thing will then simplify to x squared minus 25 and x plus 3. And you can see that, that's what this is over here. Now I'm going to do my FOIL. The first term is x squared. The second term is 3x squared. The third term is negative 25x using the FOIL cables. And the last term is negative 75. Whoops! Sorry about making that mistake over here. I pulled out a 5 instead of a 25. That's my mistake. And I already know there's a mistake down here. There should be a y in this worksheet. So if you try to do this one ahead of time, that's a problem. All right, let's look at this one. Is there a number I can remove from this trinomial to make it work? And yeah, there is. There's a number I can remove, and that number is going to be 2. Can remove a 2. And the reason why I want to remove a 2 is that makes this problem a lot smaller. So I got 16x squared plus 2x minus 3. All right. Now, this problem doesn't get as small as what I want it to be, because you'll notice that this is still a trinomial, and it's a difficult trinomial because 16 times negative 3, if you grab your calculator here, and I know I just kind of got rid of the stuff there, but this is kind of important to show you here, because what I've got here is I'm going to take 16, whoops, turn my calc on, 16 times negative 3, and that gives me negative 48. So what I got to do is list all the factors of negative 48. So what I would do is, divide the negative 48 divided by 2 and see what you get. Then negative 48 divided by 3 and see if it works. Negative 48 divided by 4. And what this will do is give you your list of numbers to check. And then negative 48 is not going to work with 5, but it will work with 6. And you'll notice that, maybe negative 48 will work with 7, but it doesn't. So there's where you're going to get all your lists here. Now I'm going to have to put back my stuff on the screen here, which I can do. Again, factoring out of 2. Whoops. Got to click this over to pen mode. Okay. Factor out of 2, and that makes this 16x squared plus 4x minus, whoops, 2x minus 3. And again, 16 times 3 is the negative 48. So we got to look at all these possibilities here. So we started out with negative, hold on a second, negative 1 and 48, which doesn't look very likely. Negative 48 and 1, negative 2 and 24, negative 24 and 2, which also doesn't make 2. Then we're going to have negative 3 and 16. Negative 16 and 3. Nope, doesn't look likely because that's no way going to make a 2. Here we go. Got to keep going here. Negative 4 and 12. Negative 12 and 4. Nope. Not going to work. Not going to make the 2. Well, let's try this next one. Negative 6 and 8. That's going to work. We won't even need to try negative 8 and 6 because this will make a positive 2 on the inside. So 2. And then what I'll need to do is separate this 2x into, I'll keep my 16x squared right there. This is going to be negative 6x plus 8x minus 3. All right, what am I going to remove from the first 2 terms here? Well, I'm going to remove, let's see, 2 works, but 3 doesn't, and so I guess it's going to be 2. So I'm going to take my 2, which is still waiting out in front here. I'm going to remove a 2. And this leaves me with 8x. Oh, I got to remove a 2x, excuse me. Whoop. 8x minus, let's see here, that's going to be 3. Now, here's an interesting thing. What do I remove from this? There's nothing to remove. Well, you can remove a 1. And that's going to leave me with 2 sets of parentheses, exactly the same. And I can put this all together. So 2 on the outside, and here I have, let's see, I'm going to have 2x plus 1, and I'm going to have 8x minus 3. And yes, there's a lot of brackets and parentheses. You can actually drop these square edge brackets and check your final answer with FOIL. So I'm going to put the 2 over here, 2x plus 1, and the 8x minus 3. Now, a question that gets asked a lot is, like, I've noticed the 2 is out in front here. If I was to put that inside one of these parentheses, would I put it into both parentheses or just the first one? You technically just put it into one of them. You wouldn't put this into both parentheses. You wouldn't make this 4x plus 2 and then make this 16x minus 6. And it's like, yeah, but I've done that before using distribution property, but there's no plus in the middle. So it only gets worked on the first set of parentheses. So I can FOIL this set here. And this would be an acceptable answer if you missed factoring out the 2 in the beginning and just multiplied 32 times negative 6. This is an acceptable answer. So let's multiply this out. 8 times 4, which is 32x squared. Oh, hey, there's my first term. And then I've got negative 12x, and then plus 16x, and this is going to be minus 6. And if I simplify that in the middle, check it out. It gives me my original problem. And you got to get pretty good at doing these problems to get to that level. This is very challenging, but again, if you're doing your homework, getting your work done, not a problem.